Good afternoon, everybody, and thank you to Ian Blackman and the COG for inviting me to present before your proceedings in this kind of unusual, and as I understand, the first ever pre-taped, recorded presentation to the audience at COG. I'm here today speaking on behalf of the IDEA, on which I'm an elected board member and have been a member of IDEA for the past 5 years. IDEA is an independent organization of a number of independent distributors who have bonded together to be able to advance the agenda, ensuring that quality standards, education, and training exist within the independent distribution community. As you can see, the reason why I'm here is specifically counterfeit electronic components. And for one reason or another, over the past 7, 8, 9, 10 years, I've gathered quite a bit of information and quite a bit of a knowledge base on this subject. So the obvious thing, the 800-pound gorilla in the room, I'm going to start by showing, and I apologize, I've got a kind of a kooky little controller here. I'm going to start with giving you a couple of examples of counterfeits. And everybody has seen these, and everybody knows that they exist. And the approach that I decided to take this year was I wanted to use some counterfeit parts that illustrated some interesting business dynamics and interesting issues associated with this problem. So as you can see on the screen, the example that I have here is a DESI part number. So here you can see an image of this. DESI part number, DESI controlled, highly regulated, highly sensitive, highly secure. So this is a part number that was purchased by a IDEA member back in 2007. If you see in the transaction overview, this was purchased by an IDEA member in the year 2007. And this was kind of right at the turning point where independent distribution and industry as a whole was starting to become aware of counterfeit products. So as this came in, rather than inspecting it in-house, the IDEA member actually sent it out of the house for third-party testing. And during that third-party testing, that's when it was discovered to be counterfeit. So as you can see on the screen, this is a DESI-controlled product. It's, as all DESI-controlled products are commercially equivalent to a very similar part, a 54AC253. This part happened to be made obsolete by National Semiconductor in the year 2005. And also with this, there's like all of these gate arrays and all these logic devices. This part also exists in a very commercial part number, an SN74AC253, which is available from, among others, TI, Fairchild, and onsemi. Post-obsolescence, post-2005, QP Semiconductor picked up this product, which is now owned by E2V. So this is currently back in production again. As you can see, here's an image of the product as it was received. As we looked at these, and these parts, just for the record, happen to be sitting in quarantine at one of our members. And it's our members as they discover counterfeit parts. Many of our membership have quarantine programs and very strict quarantine programs to ensure that these counterfeit parts don't make it back out into the supply chain. So as we looked at this very recently, a very simple marketing permanency test, 3 parts mineral spirits, 1 part alcohol, was able to remove the markings on this. Also with this product, very simply, and with a ceramic component, a simple wire cutters, you're able to pop the top off. As you look at it, you can see very subtly here, you have a different device number. So the device inside is actually an LS253 rather than the intended device, which is a AC253. So functionally, they're very different devices. I've also got included here, these are the test results that came back from a test house in the US called Analog Technologies, where they validated that this was counterfeit. And this is one of those subtle shifts between 2007 and 2011, where much of this counterfeit discovery was happening by third-party test labs. Now much of this discovery is happening within the independent distribution community and within our very specific part of the supply chain. This screen is kind of an interesting screen, and what this is, it's literally a screenshot from one of the many internet search engines out there that provide availabilities of product. Now, as you heard me say earlier, this part was obsolete in 2005, and up here on the screen, you can see right here, and it's very hard to read, I understand that, National Semiconductor product with a 2009 plus date code, about 8,300 of them. This is available, you could buy this in China today. You could call them, you could place the order, and they will gladly ship you more counterfeit products. You can see other listings and other availabilities that are out here. But if you were to go out and shop this product today and didn't have somebody who was aware of the challenges associated with this very specific part number, you may end up getting delivery on one of these items. Another item that I want to use as an illustration for counterfeit parts is an Altera product. And as you see in the program summary, it's a PLD. It's something that we're all very familiar with. They're used in applications from data display to military and aerospace. They're a very common type of product family found in the marketplace today. This transaction, this was an IDEA member who in 2007, consequently another 2007 issue, this was purchased as part of an excess inventory buy from a large telecom company. So in 2007, an independent distributor went out there and purchased excess inventory. That excess inventory that they purchased, they assumed was all good, validated, well-inspected, authentic product. As it showed up at the independent distributor's facility, it was put into inventory, and for the past 4 or so years, there was absolutely zero demand for this part. That independent distributor didn't receive a phone call or a fax or any communication saying that it was in demand. As currently, this part is not obsolete. This is currently an in-production item with quite a long lead time. The reasons for that lead time, there are so many dynamics in our business and in our industry as a whole, we could never be 100% sure of. But in the wake of the Japanese earthquake, we've seen lead times that have begun to string out longer and longer and longer. So currently there's a little bit of a shortage market out there, and as a result, one of the IDEA members received a phone call where they received an order for this very specific part. As this part was pulled for their inventory and inspected, they learned through some very simple and very basic test flows, they learned that this part happened to be counterfeit. Currently this part is yet another part that sits in quarantine at an IDEA member, ensuring that the supply chain on this particular part is safe. One of the other interesting dynamics, and I'll show you the response, is as we work with, and independent distribution works with, and OEMs work with, and our customer base tries to work with the component manufacturers, it's very difficult to get data to either prove or disprove authenticity. And we've seen cases where we've worked with component manufacturers where we've sent authentic and counterfeit product, and they have said both are counterfeit. But let's look at a little bit of the details on this. So this is one of those cases. It's a very, very, very blatant, high-risk product. You see part markings on the top. At the bottom, this part with the identical date, lot code, everything else, is carrying some other marking. As well as on the bottom, you can see that the markings on the bottom are not homogeneous. Within a given lot of product, we expect identical physical characteristics. The next step, once you see that, that says we've got a potentially risky product here, we would move on to marking permanency. And in this case, you can see how the top marking of the part very easily came off in a marking permanency test. Another method that's used to determine authenticity of product is an XRF analysis. An XRF is basically a test to determine the material or metallurgical components of the product. Based on the data sheet, the expectation is that the lead finish on this is both tin and lead. As this part went through XRF testing, it was learned that the product does not contain lead, so it would be impossible that this product is the product represented based on the part markings. Additional analysis was done on this, and it went through yet another step for the purposes of this presentation. We did a dye analysis where the product was decapped. We looked at the wafer inside, and you could see within this homogeneous, apparently external lot, there are different dye markings inside the product. Dye markings are a real challenge, and there's a lot of guesswork and there's a lot of assumptions, and it's very difficult to trace knowledge on it. And we as independent distributors and you as OEMs, as we go to the component manufacturers, more often than not, this is the type of response that we get. As we request these validation of part markings, the response was, if it wasn't purchased through authorized distribution, then we can't support it. And more often than not, and this is one of the big structural changes of our industry, as companies change ownership, as data becomes very difficult to trace back over not just years, but decades, The challenge is knowing everything that went into a production process, when in many cases these production processes happen on multiple continents, in multiple time zones, in multiple cultures.